Okay. And especially for closure, etc., because we have a lot of legacy code that using closure and the impact of isolation, and especially when we try to migrate from strict Swift concurrency, like in the new Xcode, etc. What kind of challenges that you developer can face it with closure, especially when try to use concept related to Swift concurrency? From your
Well,
experience, yes.
well, for the most part, closures are not actually all that special. You have a type
Mm,
and you want to decide, actually, this type is only safe to use on the main thread. So I'm going to put main actor. You have a closure. It's going to always get called back on the main thread. You add main actor to it. It's very similar. There are more situations because, like networking, for example, if you have a
mm,
URL session, its callback in the callback-based system is what's called a sendable closure. And that means that you package some stuff
yes.
up, you pass it off to URL session, and it is going to eventually run that closure on some background thread. It will not run on the main thread by default. It can be moved around. It
Okay.
has to be formed somewhere, and then it has to be sendable. It has to be sent somewhere else. And that is kind of that's like the whole heart of the system. And for most developers, most kinds of code, especially with callbacks and closures, you're really just deciding, does this closure have to be called on the background? And if it does, it has to be sendable. Does it guarantee that it always gets called on the main thread? If that's the case, you put main actor. And then if neither of those things are true, you can usually just leave it with no annotation at all. So for most code, now it
Yes.
can get much more complicated than that because the realities of how concurrent code can work can be very, very complicated. And so sometimes it is necessary to express more complicated situations. And that's that's something that I think you want to avoid until you feel better about the simpler cases. First, understand why you would put at sendable, at main actor, or nothing at all. And if you feel good about those, then you can start exploring some other tools if you really do feel like you need them. But a lot of code doesn't.
It's very important to distinguish between sendable and how to use sendable and main actor. Especially, we faced this using AI with this code generation, etc. We faced that sometimes some LLM come to use main actor and other for the same code, and others use sendable. And what make me a little bit fair about this, if we can't understand when we should use sendable and when we should main actor, can have be just accepted the purpose of the LLM and said, okay, he can use main actor, sendable, etc., without understanding really the difference. And for me, it's very, very that's why it's very important to me, and so I think for the community to understand this, to distinguish between when we use it sendable and this concept of sendable, what we send when we speak about sendable, etc., because we make sendable, okay, sendable. That's to guarantee that the compiler it's fine with us, no problem. Just for to said, okay, this is sendable. They handle isolation, no data races, and that's all. I think that for the majority of developers, they didn't understand first of all the origin of the name. Maybe I'm wrong about sendable, and also the difference between when we use sendable and when we use at main actor. Maybe and you are okay with me with this.
Well, yeah. So, okay, so we were talking about how isolation is this abstraction, right? It's a way of saying a thing that protects data. But what data needs to be protected? Lots of data, like, doesn't need protection at all. You don't need to protect ints. They're immutable and they hold just a value. And there's lots, if you look through your code, it's actually very normal to have lots of these data types. Maybe you decode them from JSON. They hold just data and they have no behavior or they have no references to any other types at all. So lots of
Mm.
data has the same kind of property as an integer in that it is completely thread safe inherently. And that is
It's because it's not no mutable. That's why we didn't have to add this.
immutable is not enough, but it's a start. It is a good start. So, but an integer is like a very interesting starting point because it is both immutable, but it also has no references to anything else. It is just a value.
Yes, virtual
And so
value.
that is
Yes.
safe. Now, the thing about isolation is protecting data, but what data? We don't need to protect ints. In fact, there's lots of data we don't need to protect, and we call that data sendable. Sendable data doesn't
Mm.
need protection. And that is the reason why the term was used. It actually came from Rust. So the
Mm.
term send came from Rust. But the idea is that if it's in one actor, it's under the protection of one actor. If it can leave, if it can be sent out of that actor, that's what sendable means. And I think it's more
Okay.
interesting to think about the other thing, which is non-sendable data, data that is
Yes.
not safe to leave an actor. That's the data that that isolation is designed to protect. The only purpose of having if everything is sendable, you don't need isolation because everything can move anywhere freely. There's nothing to protect. You only need to protect data that is not sendable.
Yes, in kind of actors, etc. That's why I have one of my colleague sometimes say to me, I think that we need to have actors only for managers, kind of repository, etc. In the clean architectures and managers. That's why, okay, we can move to make actors because we have maybe a kind of data races that come, but for the rest, why we need to speak about actors in view models?
Well,
I
what's
think
an
it's
actor?
accepted.
Right. So let's talk
Advanced
more about what's an actor. I think that
actor.
I made a joke one time, which was every actor needs a comment above the declaration that explains why it's an actor, and it's not allowed to be because it makes the compiler happy.
Yes.
So if you're going to use an actor, I think it's reasonable to justify why are you using an actor? Actor is a lock. An
Yes.
actor is a queue. An actor is a thread. I mean, that's not exactly true, but kind of. It's an abstraction. So why are you introducing an actor? So if you wanted to use an actor, it must be because you need to protect some data. That's the only reason you would ever need to have an actor. And then the next question is, and that's good. I like actors because actually using locks or queues manually is hard. It's very easy to forget to do the right thing in your code. Notoriously difficult, actually, with locks. So actors are nice because the compiler does everything for us, but are there downsides to actors? And there's actually a lot of downsides to actors. One of the biggest one is because an actor defines its own little bubble of protection, it only lets sendable data in and out. So now more stuff needs to become sendable. As you use more actors, you're defining more areas of protection that require communication using only sendable types.
Yes.
And so the more actors you have, the more you get pushed towards having more sendable types, usually. I think a really good mental model for what is an actor, it's much more like a network service. So if you have an actor, imagine instead of having that actor in your code, it was some network service you had to call. You had to only use network requests to do it. First of all, you have to package up the input, you have to package it up and encode it somehow, and then you have to send it to the network service. Then you have to await for this result to come back, and then you have to decode the result, which gets sent back to you. And actors behave almost exactly the same. So if someone asked me, for example, like that you said this manager type should always be an actor, I think it's very reasonable to say, okay, why? Why not a main actor type? Is the manager only holding data that gets read and read from the main thread? Probably. And if that's the case, first of all, it'll be faster because you're not leaving and hopping back and forth from to and from the main thread. It also makes it much simpler because you're already on the main thread, so you can access stuff that doesn't have to be sendable necessarily from other main thread uses. Another huge advantage of using only main thread types is you can access them synchronously. You don't always have to use awaits everywhere from other main actor contexts.
I faced the same issue when with the framework that we wrote last year about the container of dependency injection. We try to make the container as an actor, and everywhere when we try to resolve or to register the developer that use this container, it's obliged to they need to add await everywhere. And I think, okay, but resolving dependency for me, it's a synchronous thing. No need to have await everywhere.
I mean, as soon as you use the word synchronous, that's the key. If you ever have the word synchronous, it's very common for someone to design a big system and they're very happy. They're using an actor. They're so happy with it, except this one spot. Or maybe there's a few little places and you say, well, I need to do a synchronous read right here, or I need to do a synchronous access there. As soon as you say synchronous, actor is out. Actor is no longer an option. You can't store that data on a remote network service because you can't read it synchronously.
Yes, great. And if we didn't use actors at this moment for kind of things that are synchronous, but also can face the problem of data races, like the kind of the container in the dependency injection framework, we have the kind of register, etc. We can face it to this kind of problems of data races. For synchronous things, using main actors, it's actor. So main actor, it's actors. There is
that's true.
Main actors and actors, the same thing. Maybe difference. Maybe there is a difference. You can explain about difference about actors type, like a type, and the property wrappers or decorator that we can add to classes or struct like the main actor. I think there is a little bit difference. And maybe you have
Yes,
idea
there
about it.
is. There absolutely is, because that's a good point. You're right. So when you define your own actor, you're defining your own lock, your own private queue. Nobody else
Yes.
can ever have access to that queue. With a global actor, like main actor, it's a shared resource. Lots of other types can have access to the same queue. They can have the same actor. And it's this, so
Okay.
it's kind of like dispatch queue.main. It's a static variable that's shared among the whole process. And the same thing is true of a global actor. It's a shared resource. They can all kind of use the same protection in a collaborative way. And so that's an important definition, is when you declare your own actor, nobody can get access to that internal state but you. If you declare a global actor, other types can share that actor as well. Now, global actors have downsides, just like they have all the same downsides of regular actors and more. So global actors you have to be extra careful with, but that's the way that Apple's SDKs worked. They worked with a shared thread. That was the model that already existed, which is why global actors had to exist, is because they had to figure out a way to model the reality of how their SDK worked today.
Okay, understand. Great, thank you. I think that little bit of confusion is much more clear for me now, and hopefully for the community. That's why it come to another question for me about Swift concurrency and isolation, like concept. It's about correctness or performance. I think it's, for me, it's from kind of correctness, from a kind of, okay, we have